Hi, boys and girls. All right, I told you that we would conduct an experiment about Newton's second law. So here's what we're gonna do. It's kind of silly, but here it is. All right, so what I want us to do is I want us to apply equal force to two different objects that have different masses. So I'm gonna have something that's ridiculously smaller, right? And then something that's about the same shape, but much heavier with a greater mass. So when I was looking through my pantry, I decided to go with a Pop-Tart and a Cheez-It, because they're both about squares. One is, so they should have about the same amount of air resistance, slowing them down. And I decided on a flick, because when you're flicking your finger, I feel like that's the best thing you can do to try to keep the force the same with every trial that you conduct. So, right? Just about always it should be about the same amount of force. So you have these little whackers at school, but I left them there and can't go get them, so we're gonna do a flick. All right, so now what I wanna do is try to apply the same amount of force to two different objects with different masses. And what I want you guys to pay attention to, you're gonna notice how far they go. And I think it's pretty safe to assume that the one that is lighter will probably go farther, but I want you to focus on the moment of acceleration. Remember that acceleration is any change in velocity, which means that acceleration in this case would be the change from being at a stopping point to moving. So what I want you to really focus on is how fast does that change occur, right? So the acceleration will be the actual change from stopping to moving. And then of course you can pay attention to the distance too, but other things can impact the distance that it travels that has nothing to do with the acceleration, things like momentum and the mass that it has. So I want you to focus in really closely on how quickly the change occurs between something that's less massive and something that's more massive when I apply the same amount of force. All right, so I'm gonna apply a force to the Cheez-It. And you saw it moved pretty quickly, and it also went a pretty good distance. I want you to pay attention to the moving quickly part more. Now I'm gonna flick and try really hard to apply the same amount of force. And if you're gonna make a prediction about what would happen, what would you say? Think about it a second. I think it probably won't go as fast. What do you guys think? It probably won't go as far either with the same amount of force. Since it's heavier, it has more mass. And that's what Newton's law is all about. The fact that something that is more massive requires more force for it to accelerate. You notice this change from a stopping point to a moving point way slower, and also didn't go as far. All right, let's try it with something else. I have a small box of Crystal Light that is not full, and a bigger box of Mio, both drinking things, both rectangular. So they should have, there would be a little bit of a difference in the air resistance, meaning the friction that would slow it down, but at the same time, not too much. So I picked something with about the same shape but different masses. All right, so with the flick, I'm gonna try to give the same force to each one. All right, you can see that it took off pretty quick. It didn't go very far. And well, let's move this out of the way and see what happens with the more massive box. Right. It barely moved at all, and although it took off pretty fast, I don't think it took off as fast as the Crystal Light box, right? Okay, so I'm applying about the same amount of force, and the lighter one is definitely going farther. All right, there's our demonstration on force and mass and acceleration. Love you all.